Hello guys, and welcome back to the concluding episode of Amides. And of course, in this episode, we are going to talk about the reactions that reactions of amides. Okay, we're going to be looking at the reaction that amides undergo. Alright, this tutorial series brought to you by the O3 School JAMB CBT Practice app. It is all you need to succeed in your exam. In case you want to succeed, you will need the application. It has all the past questions that you need for your exam. It has lecture note structure according to the JAMB syllabus. It has question search feature where you can search for question according to topic. And likewise, it also has mock challenge every Saturday. In that mock challenge, you compete with every student, with all students that are writing JAMB for this particular year. You compete with them to win amazing prizes, to get used to JAMB past questions, JAMB likely exam questions, and to familiarize yourself with all formats that JAMB can use to test you for your exam. So also, your result will be released every Saturday as you participate in that mock exam. So it's a very, very well-loaded application for your sure success. Activate it and you'll be sure to enjoy all the utility. The app is available for download on Play Store for your Android phone, and it's also available for your laptops or for your computers. So let's just get on to the reactions of amides so that I do not waste time. So one of the first reactions we'll consider for amides is hydrolysis. Number one, hydrolysis. Okay, so we want to see what will happen to an amide, okay, when we put it in a condition where it can hydrolyze. You know what hydrolysis means? Hydrolysis means splitting by means of water. So if we carry an amide now, put it in a condition where it can be splitted, okay, by means of water, what will happen to it? What happens when amides are hydrolyzed is that they form the parent carboxylic acid and an amine, all right? And this carboxylic acid and amine that is formed can further be neutralized, okay? The carboxylic acid can be neutralized by using a base, a very strong base, okay? While the amine that is formed can be neutralized by using an acid. So let's just get on to it. Hydrolysis of amides. Okay, so when we put an amide in a condition, where it can be hydrolyzed, what happens to it? Like I said, it forms the parent carboxylic acid and an amine. So let us see that reaction. I have our RCONHR prime. This is a secondary amide. Okay, so you already know now how to classify amide. So this is secondary amide because the nitrogen is bonded to one hydrogen and one arrow group. Okay, so now if you put it in a condition, you add you hydrolyze using acid or base. Okay, and then you apply heat. What are you going to have? I'm going to have a carboxylic acid, RC double bonded to O, then OH. Okay, then plus now? Arrow NH2. Okay, so this is what I'm going to have. This one is is our carboxylic acid. While this one is is our amine. This one is our amine, this is our carboxylic acid, and this is our amide. Okay, so once we put it in the condition where it can be hydrolyzed, what we get is it's a carboxylic acid and an amine. All right, and this carboxylic acid can further be neutralized. Okay, while this one can also be neutralized. You neutralize an acid because this is an acid. You neutralize it with a strong base. Okay, while this one, since it's a base, amines are bases. We talked about that before. So you neutralize a base using an acid. So let us see the neutralization reaction. So now for acid hydrolysis, okay, if you want to neutralize this, what do? We carry the carboxylic acid, RC double bonded to O, then OH. Okay, then we neutralize using now? We use our base to neutralize. NaOH, very strong base. Okay, aqueous. Okay, we use to neutralize it. So now, once you neutralize, what I'm going to have? What will happen? This H will replace itself with with this Na, right? So let us go. We're going to see what will happen. We're going to have RC double bonded to O, okay, double bonded to O, then some bonded to O, then I'm going to have our Na plus. They will trade position. Then I'm going to have plus H2O. So this is a salt. Okay, a carboxylate salt that is formed plus water as product once we neutralize. So this is a carboxylate salt. Okay, then that is what? Water. All right, so it's what is clear as what? As daylight. Now, if we do the base as hydrolysis, that is the amine now. The amine is a base. So if we want to what? Neutralize it, what we use? We use what? And what? An acid to neutralize it. So let us go. So we can carry the amine. Let us find space. Let us carry the amine now. That is what your arrow NH2. Then what? You neutralize using an acid like ACl. If you neutralize, I'm going to have what now? I'm going to have what now? Arrow NH3 plus then Cl what minus. Okay, so this one is our what? Ammonium salt. Ammonium salt. Okay, if you neutralize what? The amine, we get an ammonium salt. If you neutralize the what? The acid, the carboxylic acid, what you get is a carboxylate what? Salt. So please take note of what? Of all that. They are very, very necessary and important. If they are not important, I will have told you so. Now let us look at another reaction that amines undergo. Okay, and of course that is what? Reduction of what? Of amides. So they can be reduced. Amines can be reduced by lithium aluminium hydride. Okay, amines can be reduced by lithium aluminium hydride. Okay, to what now? To an amine. Sorry, amides can be reduced by lithium aluminium hydride. So what? To amines. Okay, so now let us see reduction. Number 2, reduction of amides. Okay, so amides can be reduced by what? By lithium aluminium hydride, LiAlH4. So when that reduction happens, what you get is what is an amine. So let us see. I have an amide like this, RCONH2. Okay, it is being what? Reduced by what? Lithium aluminium what? Hydride. Okay, in the presence of what? Of H2O. Okay, what you give to us is what is an amine, RNH2. All right, so it's important to know that what this H2O here, okay, is to neutralize the most basic reagent at the end of the reaction. Okay, to neutralize the most basic reagent. That's why it is here, to neutralize the most basic reagent at the end of the reaction. So that is reduction of amides. Then the third reaction and the final reaction we are going to what? Talk about is Hofmann degradation. Hofmann degradation. All right, number 3. I'll talk about the third reaction. Number 1, 2, 3. So this is called what? Hofmann degradation. Degradation. Okay. So this Hofmann degradation is also called Hofmann arrangement. Okay. It's also called Hofmann arrangement. Arrangement. And what happens in this Hofmann degradation? For Hofmann degradation, a primary amide, okay, will react with what? With an halogen, and then to give us a primary amine that has 1 carbon atom less. Okay, take note of that. A primary amide will react with a what? With a primary what? It will react with an halogen to give us a primary amine that has 1 carbon atom less, and this must be done in a very strongly basic what? Medium. May be done in the what? It has to be done in a strongly basic medium. Let us look at that. So Hofmann degradation, we said that what? A primary amide, okay, will react with what? With an halogen, okay, and then what it give to us is what? Say primary amine, okay, with what? With 1 carbon, with 1 less carbon. Okay, so this is what? Hofmann degradation in what? In summary, okay? A primary amine will react with an halogen, okay, like chlorine or what? Bromine, all right? And then to give us what? A what now? A primary amine with 1 less carbon, and this must be done in a very strongly basic medium like sodium hydroxide or what? Potassium what? Hydrogen, aqueous what? Aqueous, very what? Strongly basic medium. It has to be what? Aqueous, very strongly basic. So now let us see a simple representation of this reaction. So now we have what? Our primary amide. A primary amide. So it has to be arrow. This is how we represent our primary amide, RCONH2. Then of course the reaction has to be done. It reacts with what? With bromine. Okay. Then react with what? Let's say sodium hydroxide. Then you add what? Water. Because you know the purpose of the water here also. So what you give to us is what? Is what? A primary amine plus CO2. All right. So please take note of what of that. So this is what? Hofmann degradation. Okay. A primary amide reacts with an halogen to give us what? A primary amine in a very strongly basic medium. So these are the reactions that amides undergo. There may be more, but at the level of this class, these are very, very much enough for you. Okay, so in the next class, I'm going to move into another segment of organic chemistry. Thank you for joining us throughout this series. All right, my name remains Master T. I am the Grand Commander of the O3 Schools Army. Ensure to follow us and join us on our Telegram channel where we share information for your success. Okay, so just search for O3 Schools Army on Telegram and make sure you message on WhatsApp if you need help with activating your application. Thank you for joining us.